Hey, so let's talk tokenizing text. This is part of an overall series that we have for understanding a user request when you're building GenAI applications, right? Right now, what happens, like if you use ChatGPT or something like that, it's amazing. You can type in whatever, and ChatGPT seems to be able to figure it out. Well, guess what? When you develop these applications, you need to be able to get a hold of that information, that user request, and understand it a little bit more and maybe fine tune it to make sure that your domain specific application is working the way you want, right? So, one of the things that we need to be able to understand, and again, this is in a series of training that we do, but I want to go through and let's talk about what does it mean to tokenize your text, right? And so what we're gonna learn in this section is that there are different approaches to doing this, and those choices matter downstream, right? And so what are those choices, and why do we care? And then we're going to talk about normalization and tokenization and how they kind of work together, and then how tokenization is implemented in some of the popular libraries that we use in Python. This is going to be Python specific, but I'm sure these models work other places, right? So Python has a natural language token library, and then there's Spacey. Not exactly sure what the SPA and C stand for, but you get the point, right? Pretty popular out there. And then we're going to talk about what is subword tokenizer and what does that mean, right? So different models like BERT is more of a classification model. So when we parse up words for BERT, it likes to have the whole world. The whole word, right? Because it's doing classification mostly. With the GPTs, and we're generating information, having subword tokenizers is a lot more powerful. And frankly, that's how it fixes a lot of your misspellings, because I know you guys are sloppy when you type stuff in, right? And so we'll get into more detail on that too. And so what I'm going to do is I'm going to talk through this, and then we're actually going to get into live notebooks. One of the things is that I'm the CTO of Accelerated Innovation, and we look at training differently than a lot of people. I've been on YouTube and I've gone through training, and I love Jupyter Notebook style training. But the way we build our training courses is we have sections like this, give you some high level overview, and then we're going to go into a notebook where we can practice these very specific techniques, and we can go through and play with it. And we use this environment called Codio. So it's completely encapsulated. So you don't have to worry about setting up Jupyter Notebooks, Visual Studio, any of that. It happens all inside of the Codio environment. And it's nice because we can then focus on just the training for you guys and what you need to learn. And so right now I'm actually inside of the Codio environment, and we're going to go through this. But the way we do it is I like to just high level topics. And then when we get into the notebook, we'll have very specific, detailed applications of this. So that's what we're going to do. So if you feel like I'm not giving you enough examples, wait till you see the notebook. All right. So basically, we want to break things into usable units, right? So tokenization makes it easier for the machine to read while we're in our pipeline. And then we have to make sure we align our tokenization with the expectations of the model. I mentioned with BERT, probably more whole word, works off a bag of words kind of tokenization concept. But BERT model is more about classification, and GPT requires usually subword tokens, right? And again, what we want to make sure is that we're looking at cleaning and preserving meaning so that downstream things make more sense. For example, it could mean things like making some inferences about the work that we're doing. So if we ask a question, we need to classify whether or not this is for a business. Is it a policy? Do we need to customize it? Like if I ask a question, hey, does my policy cover my glasses? Well, first of all, what are you talking about, right? An LLM is not going to know how to answer that question. But if I can infer the meaning and understand that, hey, first of all, I'm a person. I come in, I can classify me as a client or a subscriber. And so now I know if I go to the subscriber database, I can get information about me. And then if I'm talking about a prescription, that's probably some plan that I have from a healthcare provider. So now it knows to go get my healthcare plan identified in my in my client profile or patient profile, whatever, subscriber profile. And so now what happens is I can now go get that information. I can create a very personalized response. Now, we're not going to get into all that. We'll talk about that in more detail. But what facilitates that is to be able to classify what I'm looking for. Everybody's talking about agents nowadays. One of the things with agents is that, typically what we do now is we give it to the LLM, let it make its decisions. Well, if we put in a vague response like that or a vague question like that, it may not know what to do. If I do some classification up front, what I can do is I can actually put a expert system or some sort of orchestration layer on top of my agent system, and then use that as an orchestration layer and call the right agent at the right time. So a lot of things that we can do if we do good tokenization and classification of our input, right? And then, basically it's the first gate to normalization, right? Filtering out noise, handling excessive punctuation, and simplifying variation. And so when we're tokenizing text, what we're going to talk about in this section is the normalization, right? So normalization, typical things, right? We want to be able to lowercase, right? Make everything uniform. And then we're going to clean up white space. Back when I was learning to type, what they would do is they would tell you that at the end of every sentence, you leave 2 spaces, right? Apparently that's not the rule anymore. Now it's 1 space. Now, granted, there are other things that people do, right? We're typing in, we have all kinds of white space, big gaps, but they mean nothing to the language model. So why not get rid of them? Standardized symbol standardization. Just went through a major project where what the client did was they created a bunch of content using ChatGPT. It got exported to a Word document, and then that Word document was pulled into something that was really good at creating JSON. Well, that was all cool, but what happened was when it went from Markdown to Word to the JSON, it kept interjecting smart quotes because of options that were set in Word. And that became a problem, and it was a huge mess, right? And so you can think of if we're also passing these kind of things into our language models, we're basically giving the model more work to do. And the more we can cut down on the amount of work, we can cut down on latency, we can cut down on the number of tokens we're sending to it. And while that may not seem like a big deal to you and I as a casual user of something like ChatGPT, our token size, whatever, we probably don't use it that much. But if you think about building a production application where we have 100,000 users banging up against an LLM, just saving 1 or 2 tokens can save our business a ton of money, right? So we want to be thinking about that. Noise reduction, I don't know about you, but I get a lot of email where people are typing with multiple exclamation points, emojis, things like that, but they don't really contribute to the overall meaning of the sentence. Same thing with stop words, the, is, and while we're going to talk specifically in this section about English language, the same thing with other languages, right? There are models that are specifically trained on different type of languages. All right, so now we're going to go into our first notebook, and I'm going to walk you through this. And basically, what we're going to do is normalize the text. Now, in the class, when you come and we do this in person, I'm going to collapse this and have a notebook. So when we do this in person, basically, you would pair with a couple of other developers or by yourself, and you would just you would walk through this notebook and learn some really cool stuff. But the reason we like to do these sections in notebooks is that it gives you a chance to kind of experiment and play with the technology without worrying about a project. Now, one of the things we do is that it's my feeling, I think I learn a lot like when I'm learning something like this, right? You can do a ton in a notebook, but we don't deliver product in notebook, right? We're not an ML scientist that delivers their models in Jupyter notebooks. We actually have to create things into a back end, like in a back end API. All of our courses at the end of the course, we basically build up to a capstone project that is in Visual Studio, and we guide you through creating an API-based, basically in this case, it would be a tokenizer or whatever other user input determination we were making, right? So the way our courses go is some slideware, some deck like that, or a Jupyter notebook like this, where we'll go through some information, learn some things. You can play with it. Again, what's brilliant about the Codio environment is basically everybody's got their own virtual environment. So you as a student would come in here and you can break this, do whatever you want, and you're not going to affect anybody else. So it's a nice place to be. And then, like I said, at the end of the course, we have a capstone where a lot of the things that you learned in the notebooks move into the capstone and help you write the code, right? And the capstones are all object-oriented based and behind Fast API. All right, so we're going to talk through this exercise. So what we're going to do is we're going to explore text normalization and best practices by lowercasing, removing white space, standardizing symbols, and so on. So the first section here, we're just going to import some libraries. So just going to run this, going to import the libraries that we need, Unicode data, emoji to spot the emojis, and we're going to use, in this case, we're going to use NLTK and NLTK corpus, and we're going to pull stop words with it. And so in this section, we're just going to set up, this is going to be our base sentence, right? You can see this, quick brown fox, a lot of white space, some emojis, and don't laugh. I had people send me emails like this, all right? So it is what it is. All right, so the first thing we're going to do is we're going to lowercase. So we lowercase everything, and then we're going to go through and we're going to remove white space. So we're going to remove the white space, starting to clean it up. And then now we're going to look at standardizing like Unicode normalization, right? Things like, smart quotes and things of that nature. And so there's an NFCK normalization form KC library that'll help us through this. So we're going to run this. And then, so it's going to clean. You can see as we go through, it's cleaning things out. Fox jumps over the dog, got rid of the emoji, right? The emoji's gone. And then we're going to remove extra punctuation, right? So we've got a lot of, somebody's very excited when they wrote this. A lot of exclamation points. So we're going to run this. And run this, and did I run it? I'm going to run it again. Run it and get rid of all the extra exclamation points. Now what we're going to do is get rid of the stop words, right? We don't need the word the and a couple of other things. So removing stop words are common words. And you notice what we do in the notebooks is we describe to you what's going to happen. And that way, if you're just learning this, you can go through, you can add your own code. Maybe you have certain parsing or tokenization techniques that you use already, and there's no reason you can't do that. So in this putting it all together, normalization pipeline is we're going to take all the work that we did throughout these cells, and we're going to bring it into a one function that we would use in Python. All right, so now it runs through the code, does normalization, and we switched up the sentence here a little bit. And so we have, hey, check out the new sale of 50% off. It ends tomorrow. Visit our site at example.com. And so it goes in and it cleans all that up, gets rid of the extra quotes and all of that. And then to follow it up, what we like to do is give you some optional exercise so that you can, it's one thing, hopefully what you'll do is you go in and poke around in here during the course. We usually give you about 15, 20 minutes to get through a notebook, and then some reflection. So this is all part of the course. I will add this notebook to this video, and I'm gonna walk through some other notebooks. So let's talk about how tokenization, the inputs, right? So tokenized inputs, right? Token granular. So tokens can be words, subwords, like I mentioned, or even characters. And then, of course, each have their trade-offs. Not a lot of people are using character tokenization, by the way. I would avoid it unless you need to. Then we have lemmatization and stemming. And what this does is it normalizes tokens to their base form. Like gaming, better, good, better, no, sorry, better, best, and really, really awesomeness, better. And so it'll bring it down to its base word, like so, better, or grow. It'll bring it back down to grow. Basically, again, take it down to its main form. And then the type, right? So could be rule based, white space, but the model we have model specific tokenizers, and we're gonna talk about those. And then edge cases, the tokenizers, they can reliably handle contractions, hyphens, abbreviations, and punctuation and things like that. And so what you want to do, instead of, a lot of times back in the day, I would home grow this, and it was always a problem because there was always something that would show up, an extra quote we didn't think about, an escape character, some bizarre Unicode character would show up, and I don't know about it, but it would take you days. You'd have to take a file and you'd convert it to Unicode. So you're plowing through Unicode trying to find characters that don't print. Messy. Most of the models today handle all that. And so what ends up happening is we get a lot of efficiency gains, right? By reducing the errors, we can reduce the token set, and that improves overall performance and reduces compute time. And I just want to repeat that if we can cut down one token out of our request, we're making gains, right? Because input tokens and output tokens cost us money. If we're just doing it at home, ChatGPT, not a big deal. The second we start talking about 100,000, 1,000 an hour, those type of things, that can get very costly for our organization. And one of our courses, we actually go through and talk about how you can analyze the tokens used and report on it, right? Because that's a good metric to have to figure out what's going on in your system and how much money you're spending, and are there ways that you can cut that down. All right, so let's go into this exercise. And again, I'll make sure I'll attach a link to these notebooks, right? So we're going to explore key tokenization methods and libraries. So we're going to go through NLTK, Spacey, and Hugging Space model. And then let's talk about some of these things. So there are different granularities. There's character-wise, right? So I'll split every character. The typical use of these is OCR, right? And then subword is byte encoding, a word piece, unigram, and so the modern transformer models like GPT, Claude, this is the type that they like and expect. And then word-wise, basically white space split, rule based. There may be some rules in the thing to indicate where to split, and that's kind of traditional natural language processing. All right, so I'll talk through the let me clear the output. All right, so I'll talk through these as I go, but we're going to import the library. So we want emoji, NLT, the Unicode data like we had before. I'm going to bring in stop words and importing Spacey, and then we want the auto tokenizer from the transformers, or transformers from the auto tokenizer. I think that's Hugging Face, right? And then we're going to use the small model for Spacey. Spacey's got a couple small, medium, and large, and they don't necessarily think that the large model is any better. What I would do is, obviously the smaller model is going to take up less space, less memory, may or may not be good, right? You need to test these things out. And then okay, the auto tokenizer is a BERT based. Still think Hugging Face, but I can check. All right, so why does your token choice matter? So the input length, and it's really more about understanding the details, right? So let's take some sample in here, and so this is just a sample, just by word or by white space, and we're going to separate this out. And so let's talk about a short recap on normalization and tokenization. So normalization often just proceeds or interleaves with tokenization. So basically that's going to be lowercasing. Maybe we do some Unicode transformation on it. We want to remove any noise like URLs, HTML, any emojis, stuff that doesn't really give us any semantic meaning, right? strict punctuation, and so you can shift the token boundaries, you can move apostrophes, and decide how you want to do that. This is going to matter more depending on your model and what it is you're trying to do, right? And so remember, we had this small pipeline here, right, where we had normalized in the last notebook. We just copied the normalize function over, and what does it do? It took and it kind of cleaned up our sentence, right? Got rid of the extra exclamation points, punctuation, and extra words, right? And so now we want to look at tokens versus words and some of the edge cases that we're going to run into, right? So contractions, sometimes it's a problem. It depends on how you want to break up the contraction, or if you just want to bring the word together, right? They're hyphenated. Do you want to break them apart? Do you want to leave it as a hyphenated word? And then, punctuation. Do I need the dot after Mr.? And then whether we're doing emojis or other type of things. So what are these kind of edge cases that we have to understand and account for? And so you can see that this is going through just the Python tokenizer, and it goes through and we put it through just a regular text and then normalize, right? And so Mr. Smith's email didn't arrive. It was 16 degrees. And then the normalized, it's going to lowercase, take out any white space, and bring everything together. And then we're going to go through, and again, what we do with these notebooks is we give you the ability to just try the different techniques. So I'm not going to walk through the whole detail in this notebook, but what happens is we'll give you an option to try the different techniques and the libraries, right? So what ends up happening is you get a pretty good feel for how they would apply. And then while you're in the course, you're talking to your friends and they're like, hey, I use this other thing on Hugging Peace, this different model. Obviously, you go out and basically try different models, and your notebooks are here for you to experiment, right? And then we typically at the end of the notebook have some sort of stretch goal. So if we give you 20 minutes during the class to go through the notebook, for those of you that have been writing code forever, you probably fly through this and want to experiment a little bit. All right. So why is tokenization such a challenge at scale? Well, part of the reason are the edge cases, right? Not only contractions, punctuations, but you have emojis and you have text coming in from, let's say you're pulling in all the data from your SharePoint site, right? All that's unstructured. Who knows what it looks like, right? So even if you're doing some sort of tokenization to put it into a vector store, it would help to do some sort of normalization and tokenization or pre-cleanup of that data before you chunked it up and put it into your vector store. Inconsistent behavior across the library. So what happens is that NLTK may work differently than Spacey. And so what you have to do is you have to figure out which one's best for you. Also, a lot of the models will allow you to extend it. So for example, when we talk about classifiers later, Spacey will allow you to build custom classifiers. So I was working with somebody that was building he was an influencer in the agile space, and so he had a lot of YouTube videos, had a lot of soundcasts, podcasts, and a blog. And what was happening is when he brought all the information together, like if he said some basic question, tell me the Scrum events. Well, the Scrum, the events have been called ceremonies, they've been called meetings, they've been called all kinds of things, right? And so now what happens if you said daily stand-up, a model might not know, or it might randomly pick one. Well, he's a domain expert, so he needs it to always say event. And so in this case, we created classifiers that if these terms came up in a certain context, it would classify him as an event. And then that way, when we printed it out and it asked about what are the events, it would have the things that were tagged as events, right? Or I think we actually called it Agile event to make it even clearer. And then subword tokenization can be opaque, right? The algorithms don't necessarily split it in a way that we would intuitively think, right? It's not necessarily just breaking it up by syllables, which would be nice, but it would mean more to us, but not to the model, right? It's probably matching the internal tokenization for that language. And to that point, it will be different based on the language, right? Token count affects the budget, right? Like I was saying, the more garbage we have or extra things we have, those are tokens being sent to the LLM, and we get charged for those. And then also, when they get into the LLM, it has to be cleaned up somewhere, right? So why not use a cheaper, faster model up front and then feed it to the LLM, cut down on the tokens, and you decrease latency because now things are going to move faster through the model, right? Doesn't have to do all that translation. Real world input is messy. I don't know about you guys, but I've actually, and this is a bad habit now, is that a long time ago I started learning that ChatGPT was a much better prompt engineer than I was. So I would type what I wanted to prompt, and I'd feed it to ChatGPT and say, hey, can you clean up my prompt for me? And it'd do a great job. So now what happened is I just got completely lazy. I looked at one of the prompts I just typed in, and it was horrible. Half the words were misspelled. All of a sudden, I don't know English grammar. And I'm like, I swear I went to college. I'm apologizing to ChatGPT about all the craziness that I'm typing in. But it can clean that up. So, but what we want to do is we want to clean it up before our buddy ChatGPT has to deal with it. Now, what's happening is that we kind of conflate these things. GPT-5 and ChatGPT are different, right? GPT-5 is the model. ChatGPT is the application on top. So I'm positive, based on what I've seen, that ChatGPT is doing some sort of in the interface, doing some sort of tokenization, normalization before it passes it to the model. So basically, tokenization shapes everything downstream, right? So we have this seems, as a developer, this is like one of the most important things that you have to deal with, right? Because we don't think about this when we're typing it, but in the application, we can do things to help stay in line with the domain that we're working on, right? And then normalization comes first. We want to clean our input before we tokenize. Just reduces fragmentation. Like anything, the cleaner the input, the better the output. And then you want to choose your tokenizer wisely, right? It depends. Like I said, NLTK will tokenize things differently than some of the spacey libraries. And so one's not necessarily better than the other, but for example, if you go in, you can also get scores back. So one of the things you might do in a pipeline is you have a base model that you like that works really well, like maybe you start with spacey. If it comes back and it's too low, that it scores too low, you can always then kick in and call NLTK, see if you can bump that score. If not, maybe you send it to a human, right? Build some process that's got human in the loop. And then the better you understand subword behavior, the better you're going to understand how to feed the model, the current models, because they all really work off of that subword behavior, right? It's one of the reasons why, simple misspellings like the word, if you spelled flight, FLITE, the reason that something like GPT-5 can understand that is that, it's breaking that into subwords. So you have FLI and then TE. So fly, it's already thinking fly, what things are close to fly. And then it says TE. That word all in one means nothing, but it can infer the word flight from the FLI in the context of a T afterward, right? And so that's what helps clean up and understand what's going on. All right. So that was a quick run through of just our tokenization chapter inside of a larger input token and parsing in our series of understanding natural language requests. If you're interested in training, we do. I'm actually a huge fan of instructor-led training, ILT. I think it's important for developers that are building things, especially in this environment, right? We're building a lot of prototypes that we can't get into production. So it's good to have somebody that's a practitioner, like myself, that teaches these courses, right? Because not only can I get the concepts across to you, but then we can talk about real world scenarios. Like I said, when we build the capstone at the end, it's code that you can actually take and then check into GitHub. So whether it's your professional or if you're just building a like a portfolio of things that you do, the capstone projects will help you do that along with the notebooks. All right. So thank you. Appreciate it. Talk to you soon. Notebooks links will be in the in the body.